Our next speaker is Divyam Mishra, and Divyam represents what we try to do every year through Carol Perry, which is to bring a youth presenter, in her opinion, the best presenter from the Dayton Youth Forum, the Amateur Radio Forum, to present something that they're doing in terms of technology. And every year this has been a very, very interesting part of what we're about. So as Rajesh talked about his early days in college reading Professor Schwartz's book, we get a chance to look at somebody even a little bit younger who's a senior in high school, but who's deeply engaged with technology. And these youth are the future of wireless. And we need to encourage them. In the ham radio world, we called it Elmering. You were an Elmer, you were an uncle to somebody, and you helped them along. And I had several Elmers in my own career, and I don't forget it. And so today I'm teaching the Radio Merit Badge to a bunch of Boy Scouts in Maine. It's very rewarding, and you got to do that stuff. So now we're going to hear from our student. Divyam is a senior at Peak to Peak Charter School. He's got an extra class ham radio license. My gosh, I was about 25 when I got mine. He's doing research, believe it or not, even though he's a high school student at the University of Colorado with a computer science professor on, surprise, the Internet of Things. He's also been interning at several companies. He's starting an amateur radio club. And his passion is to harness technology so that it can help people live better lives. What a wonderful thought. Divyam?
Hello everyone, my name is Divyam Mishra, and first of all I just want to thank RCA for giving me this opportunity to be up here and share my ideas with you all. And I am a senior at Peak to Peak Charter School in Denver, Colorado. So today I'm going to be talking about an engineering project which I've been working on from the last year on the Internet of Things, and how I want to turn this into my business sometime in the future. So isn't it amazing that in our contemporary world we are so reactive towards our problems? We are reactive towards our own problems because we don't have that data in motion that we need today. No data, no analytics, and no predictive analytics. We are reactive in terms of our own healthcare, even in addition to the things around us. Our healthcare is either reactive or preventive, but not proactive. But can technology turn us from a more reactive lifestyle into a more proactive lifestyle? Absolutely. And that is what Probot, the proactive bundle of things, is all about. Probot uses sensors to collect data in motion, cloud storage, and predictive analytics. We have all the technology tools available for us today in order to create such a system. But can we rely on technology? That is exactly what this engineering project is all about. So in most of our lives, we are reactive. We live in a very reactive manner. We are forcefully drawn towards solving the problems that our devices constantly bring upon us. Our devices are constantly failing, and they're constantly being invalidated. And this causes us to fix these problems that come out of nowhere. For example, last winter, my father was running around trying to fix our heater a day before the first winter storm of the season. And it's Denver, Colorado, so it's not really the best thing to happen. So we were trying to find a mechanic, and it was really hard because it was a festival time. So we spent a lot of time, a lot of energy, and a lot of money to fix this heater. And later on, it turned out that only the thermostat had broken. So we spent all this time, money, and effort to just fix the thermostat. So this tells us that we are reactive towards our problems. Just like my heater failed, we react to the problems and try to fix them. But we want to have that better control over our lives. We want to fix these problems before they actually become major problems. But what's stopping us from becoming and achieving that proactive lifestyle? There are 3 reasons. First, a lack of data in motion. Second, a lack of predictive analytics and intelligent predictions with this data in motion. And third, the reliability of such predictions. So number 1, data in motion. Data in motion it's vital to understand data at rest before we understand data in motion. Data at rest is where data is just stored on a hard drive or a server, and it's not being used for anything. It's just staying there. While on the other hand, data in motion is data that's being freshly generated from sensors. It's being sent to multiple places. It's being analyzed for patterns. But let me give you an example of data in motion. Suppose we had our plumbing system in our homes and we had the water pipelines going throughout our homes. Now, in a lot of our cases, these water pipelines are prone to break and burst. What if we had sensors on our pipelines that collected temperature data and pressure data and sent this data to a centralized system? Now, that in and of itself is data in motion, and I think that's what our society is lacking today. And this can help us achieve that proactive lifestyle at first. However, without predictive analytics, this data in motion is useless. Predictive analytics provides an intelligent system to have a set known of rules or patterns to determine intelligent predictions off of data in motion. So suppose in our plumbing system, if all this data were coming into a centralized system, the system could detect patterns on this data in motion and alert users if the pressure were going above and beyond a certain limit, or if something was prone to burst. And it could let the user know beforehand it actually happens. Now you may be asking, well, what exactly is Probot though? What will it look like? Well, Probot, the proactive bundle of things, is a system that will use data in motion, store that data in motion on the cloud, and do predictive analytics on this. So as you can see, there are so many types of sensors we can use to collect this data. There's accelerometers, gyros, temperature sensors, humidity sensors, pressure sensors. And another key part of this project is trying to show all this data in motion to the user in a really awesome way using augmented reality. Augmented reality is where you have real images overlaid with fictional images to provide a very visually appealing experience for the user. So that is one of the main goals of my project. But you may be asking, what will the system potentially look like in the future? Well, there's a plethora of applications for Probot, such as within our own homes, in our cars, in our offices, within our own bodies. We can use digital pills that can gather data from around our body and send this data to a centralized system. And this system could potentially detect cancerous predictions of whether or not cancer may be prone to happen in a human body. And also within our own families to track where everyone is. However, I wouldn't want to do that since I'm a teenager. But so that's saved for last. But this system has so many applications. And where should we start in order to test the reliability of such a system? So I decided to test a home awareness system. I decided to hone in on 2 specific functionalities. One, a temperature monitoring system, and second, a security system that can detect movement within a house. So in order to do this, I had to decide what hardware components I needed to use. I decided to use a Raspberry Pi and Arduinos. So a Raspberry Pi is a little bit larger device, has a much higher clocked CPU, much more powerful, and it has Linux as an operating system installed on it. While on the other hand, an Arduino is hard-coded with Arduino C, is usually used to gather temperature and sensor data, and is much smaller than a Raspberry Pi. However, I combined both of these devices into my own system, Probot, to actually try to predict the reliability of such a system in the future. But in addition to hardware, I needed a place to store all this data. So I had options of using databases, using servers, but there was also the cloud. The cloud was a much better option for me because of 3 reasons. 1, it was affordable. 2nd, it was scalable. And 3rd, it was reliable. You can store 1 gigabyte of data every month for just 1/10 of a cent. That is extremely affordable, and you can store unlimited amounts of data. So I decided to use the cloud for storing my data. But you can't just let the data just sit on the cloud. You have to do something with it. And that's where my predictive analytics piece comes in. So I want to use something really similar to Hadoop on demand, which is a way to predict patterns from a set of data. However, in my system, I don't want to use Hadoop because it uses something called batch processing, which means that you're processing data in batches and in groups of data. However, in my system, I want something called streamline processing, which is where you constantly evaluate data, you constantly analyze data while it's coming into the system. So you're trying to give an alert to the user as soon as possible. And that is, I'm trying to use a framework called Twitter Huron. It's a Java API, and I'll be talking more about this later in the presentation. So this is the actual implementation that I have done in my system. So as you can see, there are sensors connected to the Arduinos, which are temperature sensors. This data is being transmitted to a centralized Raspberry Pi via radio frequency, a wireless protocol. And then the Raspberry Pi is doing analytics on this data and sending that data to the cloud and also sending emails to the user via an SMTP server. So this is a simplistic overview of my temperature monitoring system. So as you can see, there's a heat sensor connected to an Arduino. The Arduino is using RF to communicate that data to a Raspberry Pi, and that Raspberry Pi is doing analytics on that data to see if that data is higher than a certain limit. Such as if the data coming in were around 200 degrees Celsius, the system would send an email to the user saying that maybe your house is burning down or something like that. So this is just a more specific overview of what the wireless protocol I'm using. So I'm using the 433 megahertz on RF to transfer the data from the Arduino to the Raspberry Pi. And the transmitter is on the Arduino because that's what's actually getting the data, and the Raspberry Pi is a receiver. But in addition to my temperature monitoring system, I implemented my own security system using a 5 megapixel Raspberry Pi camera. So I used a passive infrared sensor which detects heat components and heat movements inside a room, and therefore detects data and movement based off of that. But I also, alongside with the PIR sensor, used a camera module. Now you may be asking me, well, why didn't I just use the PIR sensor? Well, the problem with the PIR sensor was that it would detect even the slightest of heat changes in the room, and it would tell me that there was movement happening in my room. So the next morning I woke up, I found thousands of emails saying someone was in your house during the night, which was totally false. So I had to implement a system that could more reliably detect movement within the house, and that's where I used a camera module. So now what happens is the passive infrared sensor detects the movement, the camera is triggered, the camera takes 2 pictures, then the system compares those images for pixel differences of more than 5%, and if the 5% is exceeded, the system notifies the user, uploads those photos to the cloud, and in this case I'm using Dropbox. So I'm using Dropbox to upload these images to the cloud, and then the program ends. That might sound like a very beautiful and simple implementation, but the problem was that if the system detected movement, it would take 10 to 15 seconds, a solid 10 to 15 seconds, to go through that entire process. So if someone were moving in between those 10 to 15 seconds, the system would totally miss it. So this was obviously really bad, and I had to implement a system that could fix this problem. So I used a Python library called Pika, which is similar to the Java library called Aka, and this allows me to do asynchronous processing on the CPU. So I could actually do 2 things at the same time on the same CPU on my Raspberry Pi. So now what happened was the PIR sensor detected movement, the camera was triggered, the camera took 2 pictures, then those 2 pictures were sent to a queue where the queue was loaded, and then there was a second program that got those images one by one and evaluated those differences for pixel differences. So now what happened was there were 2 completely different programs running at the same time. So I didn't have that problem where my system was missing out on data or anything like that. So that I'm sorry, I didn't get the slide, but that's the implementation overview that I had there. But in addition to all this, I wanted to make the system even more useful for the end user. So let's imagine a scenario where you're at work and your house is like 30 minutes away. and you got an alert saying that your house might be in danger of a fire. So you have all this traffic to go through to get to your house, and your house is burning down in the meantime. But what if we had a system that could contact first responders immediately once such a situation was detected, and these first responders could actually have insight to that data, and have access to that data? So what I want to do is I want to use software-defined radios, particularly RTL SDR, which is a Raspberry Pi specific SDR, to connect it to the Raspberry Pi. And once it does analysis on this temperature data, it can actually send data to first responders or the near police office, and tell them to, get this warning. Well, in addition to the temperature system, we also have a security system to care about. So the system could actually, if movement were detected and the user was like, okay, I saw these two pictures and there was actually a person who was in my house, then the user could have the option to notify first responders immediately. So the SDR could contact the local police department and tell them that, oh, these are the images, and apparently there was a person in their house, doing something sketchy. So that is one aspect of the project which I want to tackle with ham radio. And of course, with my radio frequency I'm already using between my Arduinos and the Raspberry Pis, that in of itself is a huge benefit, because I can actually encrypt the data, because what I'm basically doing is sending binary values, converting my temperature data into binary values, and then sending those over radio frequency. So I can actually encrypt this data and make it a very safe system. And the reason why I didn't use Bluetooth was because it was a little more expensive, and one of the goals with my project was also make a system that was affordable, much more affordable. So radio frequency was awesome for that. But as we all know, all systems have weaknesses, and I've come up with these 3 guiding questions for my further research. So the first question I have was, can we rely on sensors? The problem with sensors is that they may send us invalid data or really false data, and the system could take this data and interpret in different ways. So if a sensor randomly sends an outlier of 500 degrees Celsius, the system may use that data and tell you that your house is burning down in flames. But when you get to your house is totally fine, and that the system actually sent you a false alert. So rather than being a proactive system, this system would become a reactive system, which is kind of ironic. So we can address this by actually taking data from multiple sensors and combining them to create a more precise prediction, rather than just using one sensor and its data. The second question I had was, can we rely on cloud storage? During my research, I found out that cloud storage uses a term called eventual consistency, which means how many times your connection with the cloud provider will actually succeed. And it's 99.9%, which is may seem high, but that 0.01%, that's that 0.1% that's left, is still really dangerous, because in that 0.1%, if there's a lot of data coming through to my system, that 0.1% can determine a lot of alerts that may be useful. So that kind of asks the question, can we really rely on cloud storage? Is it really the best option out there? And the third question, by far the most important and the most complex, is, can we rely on predictive analytics? So I have not implemented a predictive analytics machine, because it is a really complex task, which I'll explain right now. But before we get into the deep stuff, we need to just come back to the bird's eye view again. We know that the Raspberry Pi is transmitting all that data to the cloud or server, and the mobile client will be able to see that data and see that analysis via augmented reality. But how exactly will this predictive analytics work? How will this backend system work? Well, this is where I have done research on Twitter's Huron framework. So there's multiple frameworks for streamlined processing, as I mentioned earlier in this presentation. There's Apache Storm, Apache Spark, Apache Kafka. But the best thing about Twitter's Huron is that its focus is on streamlined processing, and it's really efficient, and it's really cutting-edge technology. So this is a topology, which is just a bunch of nodes connected with each other. And how Huron works is it uses something called spouts, which release data into the system initially. So in my case, a temperature and pressure data would be released to the spout. Then this data would need to be converted into tuples. which is a data object type of Huron that Huron uses. So I'd need to convert all this data into tuple objects, and these tuple objects would be sent to bolts. So as you can see, the first bolt, B2, is bolts are used to do something with the data. So you can store the data, analyze the data, or delete the data. So in our case, maybe we could have the first bolt just store the data initially. Then the first bolt would send this data again through tuples to the second bolt, which could actually predict stuff or maybe filter the data. So if we had a bunch of data coming in, temperature values, and they're all between 0 and 100 degrees Fahrenheit, we could filter out the data to say, if the data is above 90 degrees Fahrenheit, then we could continue transferring this data. So all this data, filtered data, would then be transferred to the last bolt, which is the best part. The last bolt would be in charge of doing predictive analysis on this data. So now you may be asking, well, how will this predictive analysis work? How will this work on this last bolt? Well, we will use something called machine learning. So machine learning is where intelligent systems learn through experience. So as the system gets more and more data over days, months, and years, it will learn to find patterns, find more patterns, find more algorithms to actually alert users of their the problems in their homes. That may sound really simple, but machine learning is extremely complex. We still don't have a system in our world today that can actually predict stuff that's happening in our homes. So how will we do this? Well, there's something called an inductive bias, which means that, which is a machine learning term, which states that we're defining a set of assumptions that go into the algorithms that determine what patterns we can detect in data in motion. So in our case, an inductive bias could be if temperature data were coming in, we could have the inductive bias be that if the temperature were over 100 degrees Fahrenheit, then we could pay attention to that data and do something based on that data. And we could also have ranges of data, such as if the data were above 150 degrees Fahrenheit, we could have different algorithms or different biases to take care of that. However, this is extremely complex, and this leads to the actual data sets. So there's two terms called overfitting and underfitting. Overfitting is where you have your predictive analytics, your machine learning, it's over predicting the data. So that means that it's using each and every data plot that you have, and it's using that data for its predictions. Now obviously that's flawed, because if you have errors in your data, the system will use those errors in its predictions, and that could lead to false alerts. However, on the other hand, there's something called underplotting or underfitting. It's where you oversimplify the data. So if there was a huge range of data from 0 degrees Fahrenheit to 200 degrees Fahrenheit, the system could just conclude based off of half the data that your house is burning down, which is underfitting because it's oversimplifying the data, not looking at really specific enough. So the problem with machine learning is you need to find a threshold between overfitting and underfitting, which is an extremely hard thing to do, and it involves a really complex algorithm. So coming back to the whole topology thing with Huron, here the first example I showed you was a very simple example. But what the system would actually look like is have multiple spouts, multiple bolts, and they were all interconnected with each other. And this is exactly what Twitter's working on with their system, because they have so much data coming in, billions of pieces of information coming in. They need a really fast way of evaluating all that data and analyzing it. But now you may be asking, I, as a user, don't really care about how the backend is working. I only care about how I am seeing the data, how I can actually visualize what's going on in my house. And that's where augmented reality comes in. So if So I actually had an animation on this slide that when you clicked it, it was a periodic table of elements that was in 3 dimensions. So each element was its own grid, and it was laid out in 3 dimensions. And the user could actually like interact with it, tilt the entire periodic table, zoom in, zoom out, actually interact with it in person. And I think that's where IoT is really heading, because in my system, you can't just show a table of data to a user. Like, that's just extremely boring, and the user wouldn't understand anything. So in my case, I want to use augmented reality to actually show my predictive analytics to the user and also the predictions through a very visually appealing manner. So I've created this prototype of what my augmented reality would look like. So as you can see, there's a three-dimensional house which has gradients of blue and red to symbolize how warm or how cool certain regions are in the house. So if we had all this coloration throughout the rooms, throughout wherever the sensors were, we could actually zoom in, zoom out, move the house around in 3 dimensions, and you could actually have pop-ups in each of these that actually say what the system is predicting might happen. Such as maybe in this red region, we could have a pop-up saying, oh, maybe you may have an overheat in this room, or in the cold region there may be a leak in the room for temperature. So this all can tell us very intelligently and in a very visually appealing manner how we can fix our problems in our homes. So we've had a long journey so far. We first discussed predictive analytics and data in motion, how there's a lack of data in motion, and how I decided to implement this system where we get all this data and do analysis on it. However, there's still so much work left. The system is extremely complex, and there's 3 main buckets. There's predictive analytics, streamlined processing, and within predictive analytics there's machine learning, and then there's augmented reality. So all these components together will encompass a product called Probot, which will be able to convert our lives from a more reactive lifestyle into a more proactive lifestyle. So with that, I would like to thank the following people. Carol Perry, who gave me the opportunity to present here. My mentor, Professor Sriram Sankarnarayan, who mentored me through this process and guided me. My technology teacher, who inspired me to work in this field. My parents for being here and by my side with me. And all of you for listening to my presentation and the ideas I had to share with you. Thank you.
Do we have questions? No questions.
I'll ask one.
Oh, okay. Sorry, I see you.
I think I understood your motion detector to be a camera that takes an image and compares it with another image taken a little bit later. Is that right?
Yeah, that's good.
So do you need to have the lights on? What if the burglar comes in at night?
No, the camera actually uses night sensing technology, so it's included with the system. So it uses the
What, it's using infrared?
yeah.
That's important.
Yeah. Yes.
Have you put in some parameters where, since in a home situation you may have someone going from one bedroom into a washroom area, and you certainly don't want those pictures taken, especially when I'm walking around. Sometimes I don't necessarily always have my shirt on. So have you started analyzing a home situation, some of the movements inside?
So that's a really good point, and I think it's really up to, this is obviously going to be a product. It's the user is going to decide where to put these sensors. So I guess that is a caveat to that. But exactly, where exactly will these systems be placed in order to detect the best motion? Like if the burglar decides to go in through the bathroom, that would be a particular, pinpoint in the system that would weaken it. And I think that's a really good point. So yeah, thank you very much.
Yeah, we created in 1991 this kind of a analytic technology, and our problem was always we didn't have Raspberry Pi, we just had inputs and outputs. And that product kind of died for video alarm verification because we couldn't use it in the homes, and that's where most of the alarms came from, on false alarms. So there's something for you to take a look at in putting in your software development in the Pi to kind of adapt to what's going on in the house.
Yeah, thank you.
Good. And how old are you again?
I'm 17.
Last week, this old house in their thing where they roll out new products and go through examples of how to do those things, they brought out a vendor of a new zone heating and cooling system. And what this is wireless cell phone-based control, and each vent in the house is controlled and zoned and feeds back to a processor, and then whether you're in the home or outside, you can shut down and bring up rooms, adjust the temperature. And they're very economical. These new vanes
Yeah, exactly. And it's not only the temperature. I mean, as I mentioned, the system is so applicable. Even to our cars, we can detect whether our engines are going to fail or not. We can detect so many different things. And I think that's where IoT is heading, and that's our future.
Any other questions? Oh, yeah.
What companies are you following in the IoT field, and who do you think is making the most important investments in that area?
Good question. Well, I mean, ever since I was a kid, I've been a huge Samsung fan, and I think Samsung is really leading on IoT. I mean, besides the fact that Note 7 kind of ended up really badly. I mean, I myself had a Note 7, and it was a great phone, but I had to recall it, unfortunately. But I think that they are doing so much work, and they're doing a lot of work in IoT. They just launched a product. They just bought a cloud company called Joyent, and it was a huge acquisition, and they're doing a lot of research on IoT. It's just a lot of research.
Are you referring to their smart things investment?
Yeah, so they also have products called like Smart Home. If you've seen the refrigerators, they're really high tech. They have like so many sensors. They have like sensing of what foods are gonna rot, what area of your fridge is gonna actually like prone to rot, or what foods you should take out. It's really complex, and I think they are the leading company. But there are so many other companies out there. You know, Sony is getting into it. There's so many different corporations, and not only these big corporations, but the company I entered this summer, it's called Notion. They are a startup, and they're doing a lot of work. They have these sensors called bridges, and then they have actual sensors. And these sensors you just place on like your door or your window, and if movement happens, they actually detect movement. So this is a startup, and they've already did all this. So it's not only just big corporations. Like startups are doing so much work. So yeah.
Yeah, there's a lot of activity in that area, of course. So I think it really breaks down into two areas. One is the in-building, which is your talking about, mostly, managed by Wi-Fi. But there's also the outdoor component into that, and Comcast just announced that they're going to be building a nationwide narrowband wireless network based on the LoRa WAN technology, which is very exciting. A lot of people are doing a lot of work there. Very efficient, long-range radio technology, and that's coming soon as well.
Yeah, Comcast and I think Verizon just got approval for their 5G network from the U.S. government, and I think Verizon's also doing a lot of cool stuff with wireless technologies. So I think we're headed in that direction.
I'm wondering if you think the military arena would benefit from this technology that you're talking about?
Yeah, of course. I mean, right now the system is extremely basic, and the system can be implemented basically everywhere. So in the military, if we could have these systems in like the actual planes or in the actual cars, we can detect when malfunctions may occur. So if like in an F-16, I don't know, I'm just taking a random example. In an F-16, if one of the rotors in the motors were about to like fail, or there was temperature building up, we could actually detect these problems, and the pilot could do something before that could actually happen and prevent this from happening. So yeah, this system is basically applicable everywhere, I think. So yeah.
You mentioned temperature sensors in a number of instances, and for example, getting an early warning that the temperature is 200 Celsius or something, that your house is going to burn down. You would, in a real world situation, of course, you would have to worry about the fact that the Arduino or the Raspberry Pi would probably stop functioning around 50 Celsius or something.
Yeah. Well, see, that's the thing. I mean, the goal of the system is basically to predict it. Well, if your house is burning down, you can stop your Arduino from burning down. But, I mean, that's where I was getting into the whole SDR thing also. If we have this connection with first responders immediately, we can, like, solve this problem immediately. Even if in case the Arduino misses the prediction, or the system even misses the prediction, and the, like, really hot data comes in, they could contact the first responder immediately. And
If the fire starts closer to the sensor than to the
that's a problem. Otherwise you're gonna have like a million sensors in your house in every single place, which would be a problem too. Yes.
Aren't his answers wonderful?
Incredible.
for someone of his age, Carol, what a great choice. And, you know,
Thank you.